What up, calculus students? Here's the Unit 6 review video. Starting with a great question. Great question. Antiderivative of 1 over x squared. So many people are really ready to circle A because of the last lesson where it's like always you got a denominator and you got logs. But it's like, no, 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 no. Just remember the antiderivative power rule works for every power except a negative first power. So if it's x to the negative second, I can use the power rule, add 1, multiply by the reciprocal. Let's not make this mistake on a test. Negative x to the negative first is that. 30 questions on this. All right, this is a great question. There's no antiderivative quotient rule. So what do I do here? It's like not an outside or inside. You simplify, okay? You can't use a quotient rule. You can't use a product rule. So examples like this, we need to simplify. Now, you understand that this fraction could be written as just two individual fractions with a common denominator, right? And then you know you could simplify this. X cubed over x squared is x. 5 over x squared is 5x to the negative second. Then use antiderivative power rules. This is x squared times a half. Add 1. This is x to the negative first. Multiply by the reciprocal. That's a negative 1 times the 5. Negative 5. Don't forget a plus c. 1 half x squared minus 5 over x. Boom, c. Tangent's derivative secant squared. Just have to remember that. Remember your derivative rules. Secant tangent. This is derivatives. Secant's derivative, secant tangent. Sine's derivative is cosine. Cosine's derivative is negative sine. Cotangent is negative cosecant squared. Cosecant is negative cosecant cotangent. You just have to remember those. Secant's derivatives, secant tangent. Just got to remember that. Nothing fancy with that one. Okay, this guy. There's no antiderivative product rule, but it's a product. What do I do? Simplify. You're going to have to distribute this 5x. Now, how do you distribute 5x? Well, it's like, what if it was 5x times x squared, right? It'd be 5x cubed. You need to figure out what is 5x times root x. A lot of people like to write this, but it's like, I don't like that. I don't like past math classes teaching you that because this doesn't help you identify how many x's you have. 5x root x, what's that? Well, think about it. X times root x. If you x squared times x cubed, get x to the fifth. X times root x, x to the 3/2. It's a 3. So that's what I would do. I'd write this as 5x to the 3/2. Exponent properties, super important. Then power rule. Add 1, multiply by the reciprocal, 2/5. 2/5 times 5 is just 2. Here, add 1, multiply by the reciprocal, times 5 times 1/4 plus c. 2x to the 5/2 minus 5/4 x to the 4th. There you go. This is f double prime. What's f? Well, we got to go backwards every single step. So we go to f prime. We get x squared. Okay, whose derivative is negative cosine? Sine's derivative is positive cosine, so I need a negative sine. So its derivative is negative cosine. Don't think of memorizing backwards, forwards, just like know the derivatives so you don't have to memorize and you can check. Don't forget a plus c, okay? Now, what's going to be that antiderivative? Well, 1/3 x cubed. Positive cosine's derivative is negative sine. Whatever number c happens to be, its antiderivative is cx. Now, if c is 0, then it's 0, but then I'll need a different c. Okay, so something with like an x is what I'm looking for. Number, 1/3 x cubed cos x. Boom, boom, there's an x, there's a number. There you go. 7. Okay, so our first situation where we see something from lesson 2. If you take the antiderivative of e to a power, we don't use the power rule. It's like a chain. Remember, the derivative of e to the x is e to the x. So the antiderivative of e to the x is going to be e to the x. Here, I'm going to take the antiderivative of the outside. So the antiderivative of the outside is like e to the 2x. But I know this isn't correct. Because if I took the derivative of e to the 2x, it would be e to the 2x times 2. When you're taking derivatives, you need the derivative of the inside. So what I have to do when we have this like chain and we're undoing the chain rule is undo the derivative of the inside with the 1/2. So take the antiderivative of the outside, leave the inside alone, undo the derivative of the inside. It's very similar to the actual chain rule. And then we got to remember that when you do have an x to the negative first power, you don't use the power rule. Power rule only works for numbers that are not -1. The antiderivative of x to the negative first is log absolute x. So there's that 5/2 e to the 2x log absolute x. Okay. These are good multiple choice questions. Antiderivative of 3 secant squared x plus 2. 3 tan x plus 2x. Not plus 0, plus 2x. A lot of people will have that because like it's tough. Some people remember, the derivative of 2 is just 0. 2 always goes away. But no, antiderivative is that. Should have a plus c here, but you don't see any additional things there. Okay, 2 to the t. I got to remember the derivative of 2 to the t. It's 2 to the t times natural log 2. It's very similar to the derivative of e to the x. E to the x log e is the same as e to the x, which is why we don't put the log e there. So if I were to take the antiderivative of 2 to the t, I would think it's 2 to the t, log 2. But of course it's not, because if I took the derivative of that, I would get that. I need to undo this log 2, which is why I divide by log 2, or multiply by 1 over log 2. Okay? So that's necessary right there. This would be the derivative of it. This is the derivative of 2 to the t. This is you thinking that you can use the power rule for everything. Don't. So we're between B and C, and then what's the right answer? It's like, well, antiderivative of e to the x is e to the x, so the antiderivative of e to the pi is e to the pi? It's a good, tricky question. Good, tricky question. The antiderivative of e to the x is e to the x. Yes, you are correct. What's the antiderivative of e? Well, it's just like the same as the antiderivative of 5. Antiderivative of 5 is 5x. Antiderivative of e is e times x. E to the pi is a number. It doesn't have a variable. So since it's a number, its antiderivative is e to the pi x, which is confusing. But tricky. Not supposed to be like super confusing, just a little bit tricky, and people mess up on it. 10. This is undoing the chain rule. Take the antiderivative of the outside. Let's see, is cosine correct? Well, cosine's derivative is a negative sign, so I don't want that. I want positive sign, so I'm going to put a negative in front of that. But since it's like a little bit of a chain, we have x to the front, x to the first inside. I need to multiply by the reciprocal of the x. I need to undo the derivative of the inside. And let's see, is sine going to be correct? Yes, sine's derivative is cosine, so that works out. But again, I need to undo the derivative of the inside. This is lesson 2. And how do I know this, guys? From the chain rule. If I just took the derivative of sine 2x, I realize it'd be cos 2x, but then times 2. I don't want cos 2x times 2. I just want cos 2x. So that's why I need the 1/2, because the 1/2 and the 2 will get together, make a 1, and we're good. Negative 1/2 cos 2x, 1/2 sine 2x. Okay. This is a chain rule. And just to remind you of this chain rule, which only works for x to the first power in there. If it's x to any other power, don't use this. Look to simplify. What we do is take the antiderivative of the outside, leave the inside alone, then undo the derivative of the inside by having a 1 over a. Okay? So, what does that look like? Antiderivative of the outside. Stuff to the 6th power times 1/6. That's the antiderivative of the outside. Inside gets left alone. But I need to undo the derivative of the inside. I need a 1/3. Give me 1/18. 3x plus 1 to the 6th plus. Guess what, guys? Like, if this is multiple choice, and if you wanted to, you could take the derivative of every single one of these, and only one of them is going to be correct. Common mistakes are like anti-deriving the inside. And like, if you guys don't know what you're doing, this like they totally do this on purpose. They totally put in things that make you like second guess yourself. 3x squared over 2. You're like, oh, that's the antiderivative of 3x. Oh, x is the antiderivative of 1. They make you like second guess and doubt yourself. But you got to know the rules. You can't make anything that looks correct think that it's correct. You just got to know what it is. And you should be able to check. If you took the derivative of this, you take the derivative of the outside, multiply by the derivative of the inside, it's not going to simplify nicely when you do that. All right, slope fields. Which one of these could be dy dx equals y squared minus 1? So I realized, like, no matter what my x is, my slope shouldn't change. It's all about the y. So if I see slopes changing when my x is changing, I'm immediately like, boom, this is gone. As my x's are changing, my slopes are changing. Notice, like, as my x's are changing, the slope shouldn't change. As my x's are changing, my slopes are changing. So B's gone, C's gone, D's gone. It's possibly E, and it's possibly A. As your x's change, your slope shouldn't change. As your x's change, your slopes should. Oh, they do. As your x's change, your slopes should. Okay, they do. Same here. Okay. But what else do I know? Like when y is 1, dy dx should be 0. So at the line y equals 1, I should have some slopes of 0. Or negative 1 too, for that matter. Here, I only have slopes of 0 at y equals 0. If I plug in y equals 0, I should have slopes of negative 1. So that's like, process of elimination, getting things down. You have to practice these. So many of you are bad at them. X over y. First quadrant, slope should be positive. Okay, that looks good. That looks bad. So A's possible, B's not, C's possible, D's not, E looks possible. Third quadrant, or let's go fourth quadrant. Slope should all be negative. Nope, A's gone. I already got this one out. These are all negative, that's good. Nope, this one's already gone. So I'm between C and E, okay? What's the difference between C and E? Negative slopes, negative slopes. I mean, I can see 0 slopes, 0 slopes. These are all positive. Those are all positive. I'm trying to get a good one here. I mean, there's one thing I notice is that based on the y's, my slopes don't change. No, they do. They do. Here. What do you see along this axis? Sometimes I go into the corners. 5, 5. If you plug in 5, 5 into x over y, you get 1, right? As a slope of 1. If I plug in 5, 5, I should get 1. I can see that's not going to be 1. If I plug in 5, negative 5, I should get negative 1. That doesn't look right. Yep, I see negative 1. So, you could look at x's and y's, look at quadrants. You could plug in some points, get some slopes that look good. Check, plug in more points. You should see slopes. That's how you do these. It's like you're creating the slope field. You might as well, honestly, if you want to, start creating your own slope field. Positive 1, negative 1, positive 1, negative 1. Okay, let's go a little bit further. 2, 1, positive 2, 1, 2, 1 half. And you start making, all those slopes. $15. X squared plus y. Okay. Quadrants help us here. If x is negative and y is positive, dy dx should still be positive. So in the second quadrant, I should see only positive slopes. Why? Because it's like, this will be a positive value plus positive value. That's gone. So A's gone. This will help. B's gone. I should see positive slopes in the second quadrant. Wait, B's good. B's good. Sorry, B's good. B's got positive slopes. C, I got some negative slopes and positive slopes. C's gone. D, positive slopes. D's good. All right. So I'm between B and D. What do I see that's different about B and D? These are all positive in the second quadrant. These are some positive and negative in that. This is the third quadrant I'm talking about. Third quadrant. Third quadrant. So in the third quadrant, x is negative, y is negative. It depends on some stuff. Let's plug in some values like negative 1, negative 1. That's going to be 0. If I go to negative 1, I should see a slope of 0 because this would be a positive 1 plus a negative 1. Do I sleep of 0 at negative 1, negative 1? I do not see a slope of 0. Let's look at D. Negative 1, negative 1. Yeah, I can see that slope of like 0 at negative 1, negative 1. So boom, process of elimination, D. So many other ways to do it. Whichever way works for you, just make sure it makes sense to you. You're plugging in points. Dy dx gives you a slope value. You're plotting the little tiny slopes. 16. Yeah, we did this one. Log x is on your quiz. Log x is the one that fits in this one. You should know the shape of log x. Shape of log x looks like this. You should know the shape of e to the x looks like that. X squared looks like that. E to the negative x looks like this. It's like a flip over the y axis. Cos x goes up and down. And the y equals are the solutions. The solutions are the equations that fit the slopes. Dy dx are the slopes. Solutions are the equations that fit the y equals. We had this on our quiz too. I like to plug in 3, negative 3, negative 3, negative 3, because all of these have y's in the denominator. And these quadrants will help you. You end up with x squared over y cubed because we'll have a positive slope. No, it's x cubed over y squared. Positive value, positive slope. Like here. Let me do it. Walk you through this. At 3, dy dx should be positive. Okay? Which one of these is good? 3, dy dx is positive. Okay, that's fine. Oh, sorry. 3, negative 3. 3, negative 3 dy dx is positive. All right, let's look at our options. At 3, negative 3 dy dx is positive. 3 over negative 3. No, that's negative. So this can't create this because this would have a negative slope right there. This would be positive. That's good because 3 squared over negative 3 squared is positive. That's going to be 9 over 9, which is 1. This doesn't look like it's 1, but let's just pretend that it is. 3, negative 3. This would be 27 over negative 3. That's negative 9. Yeah, don't like that. It should be positive. C's gone. 9 over negative 3. That's negative 3. That's gone. This would be 27 over positive 9, which is positive 3. That's a possibility. Now, you could go off of this looks more positive than that, but let's look at this point. Negative 3, negative 3. What is my slope? It's negative. Negative 3, negative 3 gives me a positive slope of 1. I don't see a positive slope of 1. B's gone. Let's double check. Negative 3, negative 3. Yeah, is it 48? If it's frustrating. If you're dropping off a calculator, just put it on this desk. All right, so this gives you negative 3. Boom, that's why E is the correct answer. Which could be the solution to this? This is a tricky one. This is a tricky one. We know it's not cosine because cosine should be going up and down and up and down. Okay, so cosine's gone. 1 minus x squared looks like it's going to be right, but no, 1 minus x squared will end up going down like that, and that's not going to fit. E to the x doesn't fit. Doesn't go to that side. It's not going to work. It's really between this guy, D, and this guy, E. Now, you probably don't know what this looks like, but this is actually a half circle. It goes straight down. It goes straight down. Later. Stay out of the camera view. This guy actually does look like something that fits. How do you know that? You can just start graphing points until it fits. Put it there. Yeah. Plug in points. You plug in 0, you get 1. Plug in 1, you get 1/2. You can see it. You plug in -1, you still get 1/2. You can see it kind of flattens out like that. So that's why E's the right answer. It's not an easy one, but it's one where like maybe you got to do some work. Don't just guess. All right, solve a differential equation. I immediately know it's going to be C, D, or E. I just know because that negative. Y of 2 is just -2. So let's separate our variables. What do I get? 1/2 y squared equals 2x squared plus c. I'm going to multiply both sides by 2. Baked into the c. To find my point. This is 16 plus c. C is -12. Now, y squared equals 4x squared minus 12. Square root, you think y equals plus or minus root 4x squared minus 12. But I say no. No. When x is positive 2, if I plug in positive 2, y is only negative 2. Don't have that plus. We just want the minus. That's the one. I probably could have just selected that answer. Do a little process elimination. 20. Oh, same one. Y of 3 is negative 2. I see both of these answers. Like, I'm going straight to E. Because I've done this before. Watch. Y dy equals x squared dx. I don't see another negative anywhere. Antiderivative. Oh, does it have e's? No, the antiderivative of y is just y squared times a half. Antiderivative of x squared is 1/3 x cubed. Multiply by 2. Plug in 3, negative 2, giving me positive 4 equals 2/3 times 27 plus c. It's 9 times 2 is 18, so 4 minus 18 is negative 14. So that gives me y squared equals 2/3 x cubed minus 14. Square root both sides, you're like, oh, y is plus or minus 2/3 x cubed minus 14. But that's not the case. When x is positive 3, y can only be negative 2. So I just want the negative. I don't want the positive. That's why I just have the negative. We had questions like this on our quiz, and I try to warn you about it with the homeworks and stuff. Let's go 21. 21. All right, this is good, like, for response practice, too. Oh, it's a great question. Because a lot of people forget to use the power rule once they see powers in the negative. Antiderivative of this is y to the negative. This is y to the negative second. Use the power rule. Negative 1 y to the negative first, or negative 1 over y. This is 1/2 x squared plus c. Now, this is going to be a good question. It's a good multiple choice question. I'm going to show you. Let's say we find c right now. 2, 1. So I get negative 1 equals, this is 4 times a half, which is 2 plus c. I get c equals negative 3. Okay. Giving me negative 1 over y equals 1/2 x squared minus 3. I'll flip both sides. Maybe you take the opposite, then flip. Whatever you want to do. I'm going to flip, then take the opposite. Get that entire right side of the equation under 1. Take the opposite. Boom. Don't see that anywhere. I must have made a mistake. No, I didn't. The AP exam hates fractions inside of fractions. Doesn't like that 1/2 in the denominator. I'm going to choose to multiply the top and bottom by 2. Why? So that I can get rid of this 1/2. Now you multiply everything. You get this. Now do I see that? That's close, but it's not that. Oh, yeah, what's up? I can pause.
All right, you all right?
All right. It's not this one. This is not that. But could it be? Sure. Maybe instead of multiplying by positive 2, you multiply by negative 2. Then that's a positive, that's a negative, that's a positive. Positive 2, 6 minus x squared. Okay, be ready for that, guys. Be ready to simplify. That's multiple choice for you. Now, if this is a free response question, guess what? You leave your answer like that. You get full credit. Don't simplify, especially if you don't know what you're doing. A lot of you don't know what you're doing. So don't simplify in free response. But you are required to be ready to simplify in multiple choice. Well, this is easy. This is just like a lot of people freak out. This just has x's, you know? Let me just show you like how to do this by separating variables. What's the antiderivative of dy? Well, it's y. This is like one thing I showed you earlier in the lesson. It's like it's not really a big thing to worry about. You could also like move over the 1/2 and do 1/2 y, and then you just multiply by 2, and you get the same thing. But you get that. Y of pi is 1. 1 equals -2 cos pi plus c. Cosine of pi is -1, so that's positive 2. C is -1. -2 cos pi minus 1. Bam. Really, what I probably would recommend you do is don't separate your variables. You just have x's. You can think of this as like f prime equals 2 sine x. You just take the antiderivative to get f. All right. Number 23. 2 over x. Okay. Well, f is 2 log absolute x. I know that. This is 2x to the negative first. The power rule does not work for a -1 power. Don't forget your plus c. F of root e, which is e to the 1/2 equals 5. The log of e to the power is the power. If you wrote it as root e, you'd be confused. If you wrote it as e to the power, that's a 1/2. Then you're like, oh, that's easy. That's just 1/2. Subtract by 1, c is 4. What's f of e? Okay, sure. So f of x is 2 log x plus 4. This is like the quiz questions I gave you, so it's easy to grade. F of e is 2 log e. Log of e is 1. We should know that. 2 plus 4 is 6. Almost there. 24. Good differential equation with just y's. What would I do? Move the y's. Leave the constant to have something attached to dx. Divide by y squared, multiply by dx. We should be comfortable with this. Antiderive both sides. Power rule works. For a negative second power, get -1 over y. Over here I get 2x plus c. 1 -1. 1 equals 2 plus c. c is -1. -1 over y equals 2x minus 1. Flip both sides. Take the opposite of both sides. Y equals -1 over 2x minus 1. Plug in 2. -1/3. No x's. What do I do? Move the y's. It's going to be one of these. Leave the constant. This is good for differential equation free responses with dB dt, dw dt. Move the w's, move the b's. Leave a constant to be with dt. Hopefully you know what I'm talking about. If you don't, do your free response questions from lesson 3, lesson 4. 0, 3. That's annoying. Oh, it's not bad. C is -1/3. -1 over y equals 5x minus 1/3. Flip both sides. Take the opposite of both sides, or do it in the opposite order. You don't see that as an answer. Why? Because of that 1/3. Multiply the top and bottom by either positive or -3. We'll figure that out later. -3 over 15 minus 1. 15x minus 1. Nope, they want that to be a negative, so that's a positive. That's a negative, that's a positive. 3 over 1 minus 15x. There's a lot of questions. What are these? They're good questions. These are good questions. Another differential equation. that we may need to simplify. This is fun because like shows you where you might have to simplify, where you wouldn't have to simplify on the free response questions. Here, divide by y, leave the 2x, antiderive both sides, log absolute y equals negative x squared plus c, e to the power of both sides. Ignore the absolute. Rewrite this as e to the negative x squared times e to the c. E to the c is just a c. We move c into an advantageous position. Y of 1 is 4. Here's where we don't simplify in free response, but we need to for multiple choice. 4 equals c e to the negative first. I'm going to write c as 4 over e to the negative first. Okay. Now my answer that I get, combining those two things, is y equals 4 over e to the negative first times e to the negative x squared. I hope to see that. Of course I don't. So what is my answer? Well, maybe I can rewrite this as 4e to the first. And maybe I can combine my exponents to realize that this is y equals 4. Okay, when you are multiplying, you add, right? So this is x to the 2 plus 3, x to the 5th. Cool. E times e to the negative x squared, e to the negative x squared plus 1. Boom. That's how we get that. So, ready to simplify. For your test, if this was a free response question, leave it like that. You don't get any bonus points for simplifying. 0 bonus points given. 0 care given for simplifying on free response. All right, this is good. Separate our variables. We get intimidated by that x minus 2 in parentheses. Don't be intimidated. Just take the antiderivative of the x and the antiderivative of 2. There's no exponent here that's going to make things difficult. So I get log absolute y minus 2 over here. I get 1 half x squared minus 2x plus c right there. Y of 4 equals 5. I'm not plugging that in yet. I'm taking e to the power of both sides, giving me, ignore the absolute value, ignore the plus or minus, you're going to work it out. Rewrite this as e to the 1 half x squared minus 2x times e to the c. Rewrite this as c e to the 1 half x squared minus 2x. Y of 4 is 5. 5 minus 2 is 3. C e to the, oh boy. Plug in 4. 16. 16 divided by 2 is 8. Oh, that's sweet. Minus 8 is 0. C is 3. Look at that. Okay, so I get y minus 2 equals 3 e to the stuff. Don't forget to add the 2 to solve. Boom. Okay. 28. Separate your variables correctly. Multiply by the 3y squared. X minus 1. Antiderive y cubed equals 1 half x squared minus x plus c. What's the general solution? Take the cube root of both sides. Cube root is the same as a 1 half power. 1/3 power. There you go. 1 half x squared minus x plus c to the 1/3. General solution just means with the plus c, particular solution, you're finding c. Oh, this is fun. You don't have to worry about separating your variables because there's no y's. This freaks people out, but don't let it. This is just like f prime equals. I'm going to write this as 1 over log 2 times 1 over x. Why? Because if I took the antiderivative, this is just a constant. Leave it alone. What's the antiderivative of 1 over x? Log absolute x. That's it. One more.